We were just continuing the geometry unit here, still dealing with a lot of ideas involving congruent and supplementary. And what we worked on those first 2 pages are just this idea that we have 2 parallel lines. The way we know those lines would be parallel would be either you're told that in the setup of a problem, or if you see these arrows here on the line, that's telling us that those 2 lines are in fact parallel. Then we would have a third line that cuts these. All right, it intersects these. This is what we called a transversal. And then that transversal creates 4 angles up here. It creates 4 angles in that second line. And then there's relationships between those angles. So we had alternate interior, alternate exterior. Alternate just means opposite sides of the transversal. Same side interior, same side exterior. And then we had corresponding angles, like upper right-hand corner, like angle 2, angle 6 are corresponding. They're both upper right-hand corner. Angle 4, angle 8, both bottom right-hand corner, right? Those are corresponding. The properties that we got through right at the end of the period, we didn't really get to practice too many of these, were these guys now, because this is not what we're going to use for the properties on the back. If we have alternate interior angles, those are congruent. Alternate exterior angles are also congruent. Okay, so we want to understand that. We're going to apply those here when we start doing these problems in a second. When we start talking about the same side interior or same side exterior, any same side angles are supplementary. And then the corresponding angles are going to be congruent. They have the same degree measure. Okay, so it is these properties then that get us through the set of problems here on the next page, or at least on yours, I think it's the bottom, and then into the next page. All right, so if we go to example 2 there, one. Start pretty simple. No algebra here, just understanding our properties in terms of what angles do we have and then what's our relationship. So when you look at example 2, here's our 2 parallel lines. We see the arrows on the line that tells us that those are in fact parallel. This would be our transversal. So the first thing we have to identify are what are these 2 guys' relationship with each other? Are they corresponding? Alternate interior, alternate exterior, same side interior, same side exterior. So here's our transversal. We'll kind of walk through this together. These are both on the same side of the transversal. So we kind of start with that idea. They're both on the same side. And then interior means that they lie in between the 2 parallel lines. Do both of these lie in between those 2 parallel lines? Yeah. So these are same side interior angles. So yesterday, that's all I asked you to identify. What are they? Of our new 5 kind of vocabulary words there, same side interior, all that stuff. Now what we're applying is this idea that same side interior angles are supplementary. So with that in mind, supplementary, we tested on, we did pretty good on that. We would know that those have to add up to be 180. So if we know that this angle here and angle 5 need to add up to 180, doesn't angle 5 have to be a 100-degree angle? So that 180 add up to be our 180, okay? So that's now what these problems get into. Identify what kind of angles we have, and then what is their relationship, okay? All right, so letter A. Here's our 2 parallel lines. We have the arrows here telling us that these guys are parallel. You then have your transversal right here. Here would be the inside. Are either one of those angles an interior angle? No. So these are both exterior angles. So if we revisit sort of these properties here, here is an exterior angle. Here is an exterior angle. So the question is, are they on opposite sides of the transversal or on the same side of the transversal? So if we look at that, the red line is your transversal. Are they on the same side or the opposite side of this transversal here? What is it? Good. These are on opposite sides. So these are alternate. Opposite meaning alternate. That's what alternate means. Alternate. And then they're outside of the shaded region. So they're alternate exterior angles. That's what we would call them. If we then revisit our properties, alternate exterior angles, this is number 2, are congruent to each other. So if I know one of them is 42, that means the other one is 42. So the measure of angle 8 would have to be a 42-degree angle. All right. Notice how there's no algebra here, just knowing our properties. We're just using numbers. When we then get to example 3, then now we're going to apply some algebra rules to this. All right, so as we look at these, find angle x. Angle x, or the measure of the variable x, we should be able to do that one. We could have done that one before yesterday. So find that one first. All right, can anybody give me a setup that would give us this angle x here? What are we doing? Julia? Good, because these are what? Good. So she used an old idea that this angle here, this 42 degree angle, and the angle that includes the value of x, these are vertical angles. So this is what we would have tested on last week. The whole idea of vertical angles are congruent to each other. So the equation that she set up was that she understood 3x minus 6 must be equivalent to 42 degrees. That's on our equation. We can then go through, solve this for x. So you'll add that 6 over. Divide by our 3. What'd you get for x there, Julia? Good. Now, again, we got to make sure we're answering questions here. So x is important. That's what we need. So you're going to put that there. But then I need to go figure out what y is. All right. So hopefully this one's pretty easy. These aren't necessarily hard, but kind of the first time doing this, this is an x, this is a y, this is a z. So we want to kind of clue into the fact that we're dealing with some different variables here. So you now have a couple of options. I'll kind of show you two options that just don't work, but in terms of our theorems, they would. Don't these two guys here have to add up to be 180 degrees? However, if we try to do that, so don't necessarily write that down yet. If I try to add these up and set them equal to the 180 degrees, well, this is a completely true statement. Notice how we have different variables involved here. That's kind of telling us that's probably not the way we were going to be able to do this problem, even though it's true. Another idea that we could do, the idea that this angle here, so let me erase some things, and this angle here of our new stuff now, if we look, if this is our transversal, these are our two parallel lines. Of the 5 options, alternate interior, alternate exterior, same side interior, same side exterior, and corresponding, what are these guys to each other? What kind of angles are these? Yeah, good. So those are same side interior angles. Understand what same side interior angles mean again. Same side interior angles is for us number 3. Same side interior angles are supplementary. That means those two angles should add up to be 180. So don't write this down just yet, but 13y plus 8 added to 3x minus a 6 better equal 180. Initially, we wouldn't want to do this because these are different variables. We have that x and the y. However, can't we now figure out what this angle right here is? All right. Because once I know that x was a 16, I'm going to take this 16, I'm going to plug it in for x right here. So I'm going to do 3 times 16 and then plus a 6. That's going to be 48 plus 6. So we now find that this angle right here must be a 54 degree angle. What that now allows us to do to set up our equation, now I don't have two variables. I'm going to take this 13y plus 8. I don't have to worry about saying 3x minus 6 anymore. I know that's a 54 degree angle. And when we add those up, since they're supplementary, those must equal 180 degrees. All right, follow that. Okay, If we do, then we just solve this equation. Combine your like terms. So we're going to add the 8 and the 54 together. Continue to solve. We're going to subtract 62. And when we solve this now, this is going to give us y. This is the second piece of information that we were looking for. So 13y now equals, what is that, 118? Divide. By 13. I'm running out of space here. So divide by 13. Ooh, does that go in there? Is it 8 times? Let me throw that into your calculator. I think it's going to be 8. Hopefully, otherwise it's an ugly decimal. 8, 13. No, is it a decimal? It is a decimal, isn't it? Oh, what was I thinking? What is it, Ella?
Decimal is 9.07.
Okay. 0.07. Let me make sure I didn't screw. Why did I do that to you guys? Yeah.
What do you subtract 6?
Oh, okay. Good call. All right. Thank you. I was wondering why I gave you some ugly numbers. Good. So go back. So there's a couple people had your hands up. So notice where I screwed up. So come back up to here. So notice how this should have been 3x minus a 6. I did 3x plus a 6. So let's change that real quick. So minus a 6, minus a 6. So that's going to require quite a bit of changing here. So this actually should have been 48 minus a 6. So what that then tells us is this is a 42 degree angle. Thank you, Mo. If you think I screw up again, tell me sooner. Okay, if you see that. All right, so that's now a 42 degree angle. So now let's go back to this. And this should hopefully work better. Not that decimals are impossible, but I try to give you some nice numbers here. So now these are our same side interior. So 13y plus 8 added to the 42 degree angle, that needs to add up to be 180 degrees. Okay, this is looking much nicer already. Okay. Add your like terms here. So the 8 and the 42 make 50. Subtract that 50 over. So we get 13y equals 130. And then now much nicer, we get y to be a 10. All right. All right, now that we have y, find z. See what you think for z, because there's really, there's probably 3 or 4 different ways you could get z at this point. So see what you see first, because what you see first may not necessarily be what I would do, but get z and see if we can come up with it. As you finish, some people are putting this down, some people are plugging into their calculator, so we're getting to the end of it. We'll do it here in a second, but again, I kind of want to see what people see first because it might not be the same as everyone. Looks like z should be a 20. So if you, whatever way you set it up, if you get a 20, then you did that way correctly, even though it might not be the same way everybody else is doing it. Okay, Omar, you got 20? All right, how'd you do it, Omar?
I did 2z plus 2 plus 138 equals 180.
Okay, so here's what Omar did. Omar did the idea that we have this line right here, and these two angles together need to add up to be 180 degrees. So what he did is he took this 2z plus 2, So I'll shade this one in yellow. So we're going to take this angle here. We're going to add it to this angle. But notice he didn't use 13 plus 8. He actually found the degree measure of this angle. So we took this y value of 10. He plugged it in. What did this angle become? Oh, yeah, that's a 138 degree angle, which it would have to be, right? Because this is 42, that's 38, supplementary. You could have also plugged it in to get it. So then we add that to 138, and then these two angles together have to add up to be 180 degrees. Okay, old idea, what we tested on, that linear pair. So we go through, combine our like terms right here. We get 2z 140 equals 180. Subtract that 40 over, so we get 2z equals 40. Divide by 2, and then that's how Omar got 20. All right. Anybody do it differently to get that? Lily, what'd you do?
I did 2z plus 2 plus 42.
And how did you know that this angle here? So she took 2z plus 2, and you said it equal to what?
42.
And how did you know those were equivalent?
Because the corresponding is
Oh, good. See, that wasn't even what I was going to shade. She saw this angle up here. Aren't the two yellow angles that I have shaded right now, aren't they the both upper right-hand corner? So those are corresponding angles. And through our theorems here, corresponding angles are congruent. So we actually could have done that one right away. Like we could have done that one right at the beginning, understanding that this angle and this angle have to be congruent to each other. And then if you now notice, when we solve this, you get the 2z equals 40 again, and then that z will also be a 2. What I was about ready to shade, so this is what I thought she had done, is didn't we have found that one to be a 42 degree angle as well? And I was thinking alternate interior angles. Here's our two parallel lines. These are alternate interior angles. Those are also congruent. That's another reason those could be set equal to each other. Okay. So a lot of different ways we can kind of work our way through these. Okay. All right. Last one. I'll give you a couple minutes. We got a little time to burn here. Solve that guy. Find A, find B, find C. Yeah, go. We did it 2 days ago. Yeah, we're all getting B pretty good. We're all getting B pretty good, so that's good. The measure of angle B here. Jada, what'd you get, Jada? Good. 75 degrees. So old idea. We know this is a triangle. We have two of the three angles here. So the B, 65 and 40 need to all add up to be 175. So good. It's 75 though, right? I wrote that wrong. So that should be 75 degrees. All right. So walking around, everybody's getting that. I didn't go all the way around, but so if this is now 75, we really didn't need to do this one first, by the way. That's probably the one that everybody sees right away is the easiest one, which is true. We really could have done C and A very quickly as well with no work. You wouldn't have had to pull out your calculator. You wouldn't have had to punch anything in. We could have found those very quickly. The reason for that, notice how these arrows are on these two lines. Doesn't that mean these are parallel lines? And if I now sketch in right here, so it's a little more obvious, this is what we are calling our transversal. All right. Did you get C, Jada? You did? Good. So if these are our parallel lines, here we're used to seeing the transversal go through. It's not critical that it does that. But if we did that, what did you get for the measure of angle C, Jada? Good. Because angle C and angle 40, what kind of angles were those, Jada? You remember what they're called? Good. Alternate, interior, close enough, Jada. I know what you meant. Alternate interior angles. They're on opposite sides of the transversal. They're inside the parallel lines. If we revisit our little theorems up here, we would see that alternate interior angles are congruent. So if I knew one of them was that 40 degrees, that means this must also be 40 degrees. Now, my guess is a lot of people's first thought is, oh, I now know this is 40, this is 75. A added with those must equal 180. 100% correct. A good thought to have. However, it will require a little more work than is necessary. Because again, if these are our parallel lines, can't we also now say that this segment is your transversal? So wouldn't angle 65 and angle A also be alternate interior angles of each other? So what does angle A have to be? Got to be 65. All right. You can test all of these now. If you did 65 plus 75 plus 40, I promise that will add up to be the full 180 that it's supposed to be to get that full line. Okay. All right. Homework. We'll do a couple. There's a couple. Typically, this invokes a lot of questions the next day anyway. So we'll kind of head that off. So we'll do a couple together. Okay, I'll leave you the first ones. This is just what we did at the beginning yesterday. You're going to look at these angles, identify same side interior, same side exterior corresponding. Just give them all names. Okay, that you can kind of look at your notes. You'll be able to figure that out. Go to, I want to do one of these, and I want to do especially one on the back. Go to number 11. Let's start with 11. Take a minute. Since this would normally just be homework, you're doing this on your own anyway. See if you could do 11. Find out angle X, find out angle Y. Okay, the nice thing about this is, do we agree whatever we get for X is what angle Y also has to be? or vice versa. Angle Y and X have to be congruent. So once we have one, we actually have the other. Those are vertical angles. Okay, anybody know then what X and Y should be here? What do we think? What do you got, Jada?
180 minus 120 equals 60.
Good. So she's saying she did 180 minus 120 is equal to 60. And you did that for what angle, Jada? Technically, that is fine. Which one? But in terms of our properties, we're technically finding X right there. That's got to be 60. And once we know this is 60, then angle Y must also be 60 degrees. The reason we know that, just so we understand, here's our two parallel lines. They have the arrows on them. Here is the transversal cutting them. Notice how they're on the same side of the transversal and they're inside of those two lines. So these are same side interior angles. Same side interior angles are supplementary. These had to add up to be 180. That's why she did 180 minus the 120. Okay. All right, 12. Do 12. X should be nice, hopefully. Cross my fingers when I say that. So if I ask you what angle X is, that's one you, no, not necessarily. But I would think that's one that we probably see first. All right, Monica, what do you get for angle X right there? Good. That's got to be 50 degrees. And my guess, we get that. This is just a line. These two angles there must add up to be 180. We had 130 of it. This has to be a 50-degree angle. Okay? So let's make this 50 degrees. All right. Can anybody tell me what angle Y is then? Who said that? All right. Why, Jason? Okay. There is an element to that. So we talked about that yesterday in terms of determining. Let me pull the notes back up here is what I was looking for. If you're not sure if these combinations they're all either supplementary, right? Supplementary or congruent. It's one or the other. So if we know they're one or the other, you can kind of use your eyeball test a little bit if you don't necessarily remember. So what he is saying is when he looked at these guys, knowing that they're either supplementary or congruent, that when he evaluated kind of and guessed what is the degree measure of this angle and what is the degree measure of that angle, does it make sense that those appear to be about the same degree measure? Yeah, and there is an element to that. If we kind of forget all of these rules, that is not necessarily the worst thought to have, is do they look congruent with these? All right. Now, because I'm a math teacher, we're going to formalize it a little bit. How could we formalize it? Sort of what theorem, what kind of angles were these two yellow angles, Mo?
Oh, I don't know.
What were you going to say?
I was gonna say they're same sided exterior.
Okay, I like the exterior part. Because here's inside of the two lines. But if this is our transversal here, Mo, isn't Y to the left of it, X to the right of it?
I'll sum up the 130.
Oh, okay. Okay, got it. So what he did, and again, this is why I shouldn't assume you all see what I see. So he's looking at this guy here and this guy here. So these are now same side. He evaluated this as same side exterior and aren't same side exterior angles supplementary. All right. So that's the way he did it. All right. Again, 100% correct. I was looking at it more as these two angles that I have highlighted here, and I would interpret these as alternate, because now they're on opposite side, alternate exterior angles, and those are congruent. And if I know this is 50, then that's got to be 50 like Jason told us it was. Okay? So a lot of properties there. All right, last one, the one that we got to go through usually anyway when we come together the next, actually, yeah, I want to do the very last one for sure. That's the one I want to see. I just want to see if I want to do one of these equations here. Yeah, let's do. Now let's just go to the last one. I want to leave you those. So go to the very last question, and you have this graph over here. A lot of angles to find. You are given the degree measure of two of them. You are given that this is 42 degrees. And then you are given that with this little square right here, this is a 90-degree angle. And with just that piece of information, we should be able to work our way around that entire graph and come up with all those angles. Okay? So, like a little puzzle here, you got to find one to get the next, to get the next, to get the next, and just kind of move on down. And then eventually we have them all. Okay? So, take a few minutes, see if we can come up with that. parallel angle like this. And when we have a line that intersects both of them, then it creates all these different relationships. And one of the relationships is, so see the parallel lines? See how there's an area in between. So angle 2, 3, and all of these are inside of those two lines. And then angle 2 is opposite side of our first one. So on the left, so on the right, so we call alternate interior. And alternate interior angles are different. That's 42. That's got to be 42. Right? If we know that's 42, then this is actually vertical. Full like that. Right, then it's going to be vertical. So, and then it just kind of systematically, eventually, we start putting them all together. So, okay, about 30 seconds here. A lot of us are getting there. Let's see if they're all right. All right, a couple different places we could start. I'm going to start with this set of 4 angles up here. Okay, you don't necessarily have to. Like, I know angle 4 right away. Before we find any of these, you could say what angle 4 is. You can say angle 8 right away. So there's different places you could start. My guess is, though, looking around, most people did kind of start with angles 1, 2, and 3. All right, so if I look at this right here, Ben, what's one of these angles that we would know? Is which angle? Good. So angle, the yellow angle here that we know, and angle 2 here, those are vertical angles. Old idea, they're across from each other. So we would know that this angle here is a 42-degree angle. So if you go to your angle 2, you should have 42 for that. All right, then if I know that's 42, Joel, what would angle 1 have to be?
138.
Good. And you could either do this line, and then these two angles add up to be 138. This is probably easier to see. This is also a straight line, so these angles have to be 138. So either line you look at, angle 1 ends up having to be 138. And then, Joe, that also means what other angle is 138? Good. Angle 3 must be 138 because those are vertical, or they also make up a straight line. Again, different ways we can kind of see that. So that should be pretty good. Again, different routes you could take. I'm going to go to angle 10 because that's probably the next easiest one. All right, angle 10. Tomas, what does angle 10 have to be right here? Good. This is also a straight line. This is 90 degrees, so this would have to be 90 degrees to make sure we get a full 180. So angle 10 is 90. Now, as we start working to these, this is where you can kind of do some different things. So can anybody give me sort of the next one we would get here? Yeah, Assad? Good. Angle 8 must also be 90 degrees. A couple different ways to look at it. The yellow angle up here and angle 8, those are corresponding angles. Corresponding angles, so upper left-hand corner have to be congruent. Or the same side interior angles here are also supplementary. So those would have to add up to be 180. All right, so that's a 90. All right, what do you got else you got there, Assad?
7 is 45, 6 is 42.
That I'm going to disagree with. So he said 7 and 4 are both 45. I agree that angle 7 and angle 4 have to be the same degree measure because those are vertical angles. So whatever you get for one, you're going to get for the other. Don't assume that that gets cut right in half. What do you got? See him? All right. So angle 4 is 42 degrees. If we're going to talk about y, then here's our parallel lines. Here is the transversal. So aren't angle 2, so this guy and this guy, aren't these alternate interior angles? And alternate interior angles are congruent. So that's where she got the 42 degrees from. And then like Assad knew, 4 and 7 have to be the same. So once I know that's a 42 degree angle, then angle 7 is a 42 degree angle. 5, 6, 9, various ways we can get these. Anybody want to give me 5, 6, or 9? Now, Assad, what do we get?
5 and 9.
Good. 5 is a 90-degree angle. That is vertical to the 90-degree angle across from it. Do we agree then, now that we are down to these two and these two only, that angle 9 and angle 6 are vertical angles? So whatever we get for one, you got to be able to get for the other. All right, what do we get for one of those? Yeah, Assad.
42.
Now 42. Mo.
138.
Oh, for angle 9. Let's think about that in terms of if that would be okay, because this angle 90, this angle 9, and this angle 42 make up a straight line. So all three of those need to add up to be 180. So if I made this 138, this would be too big, too much stuff there. All right, I saw Tyler first. Go ahead, Tyler. What do you got? Good. That should be 48. And how did you do that, Tyler?
I added 90 and 42, and then I think the 138.
Good. So he understood this whole thing was 180. We had two of the three, the 90 and the 42. So we just need the extra 48. He added them all together to get the 180. Okay. So that should be all. If you got them all, good. And then angle 6 then obviously has to be 48 as well. Okay. Okay. So have that done. Collect that tomorrow. If you have any questions, again, there's some on there that make you think some. We can go over a little bit tomorrow. If I see you tomorrow, of course. Yeah.